Hey everybody, great to see you. Great to be in Toronto for, I think, the first ever FIL Toronto meetup. So it's really good to start bringing that community together. What I want to talk about today is the Falcon master plan, and I'll just give you an overview of the goal set of Falcon. And I'm going to blaze through this pretty quickly, but then I want to do Q&A. So whatever you're most interested in talking about and asking about, I want to use that to kind of dive into any one of these parts. So I'm going to go through a lot of it fairly quickly, and then if you have, then I'll do most of the time in Q&A at the end. And a huge thanks to the FIL Swan team for putting all of this together and starting to build the community here. I remember early IPFS and Falcon meetups being just getting started kind of like this, and it's great to start bringing the community out and create a regular cadence event. And so I remember even things like ECC and like the first DevCon. I remember the first DevCon room was smaller than this. So, and now it's like a massive, massive conference. So really good to get this started. Cool. So Falcon master plan. Web3 is bringing trust to internet interactions. So you can think of Web 1 as a read-only static medium to diffuse information. Web 2 brought read-write interactivity. And now Web 3 is bringing trust to interactions. We're doing that with cryptography and cryptoeconomics. However, the problem is Web 3 right now is not web scale. When you think about the scale of operations in a typical web application, we're talking massive scales of data, massive scales of computation, massive transactional volumes. Today, Web 3 is tiny in comparison to that, and no single blockchain can handle that kind of throughput. In order for Web 3 to cross the chasm and be adopted and realize that vision, Web 3 must become web scale. So Falcon aims to enable that. Step 1, we're going to build the world's largest decentralized storage network. Guess what? We've done that. Step 2, we're going to onboard and safeguard humanity's data in that network. And then step 3, we're going to bring computation to the data to enable those web scale apps. So step 1, already achieved that. In great part because of the massive achievement and work of the Falcon storage providers. We're now at a 17 exabyte scale storage network. And so this is not just the largest decentralized storage network by far. We're talking many orders of magnitude larger than the next decentralized storage network. But this is now competitive with centralized cloud companies. And so this is becoming, it's not as big as the big three, but it's getting there. It's getting to that order of magnitude. So if we grow by 2-3 orders of magnitude, like this is the largest storage network on the planet. And the network capacity is growing at a super fast pace. 26 petabytes per day is huge, and this is even through massive macroeconomic shifts and and crypto market shifts and so on. And so the capacity of the network continues to grow at a super large scale, and over time we can get to much greater scales of the network. The storage providers are growing, and more are joining every day. This is a large, complex visualization, but you can see the cohorts of storage providers sort of graduating. The blue circles show the inflows of the kind of prior periods cohort graduating into the next largest, the cohort of the next largest size. So you can see storage providers over time growing, and more storage providers joining every day. There's now a ton of content and accelerators to help storage providers get started, and it's part of what's fueling the growth. We also want to make sure that as we're building this, we build the greenest storage network on the planet. And the goal is not just to get to carbon neutral, but we want to become an actually climate positive network. We want Falcon in the world to decarbonize the planet, so that when you have Falcon in your area, that is literally pulling carbon out of the air. There's a lot of steps to get there. The Falcon Green project details out the plan of how to get there. The first part is getting to making sure that all of our energy use is coming from renewables, and then after that, starting to bring carbon out of the air and fix it. Great, so that's step 1. Now step 2, let's onboard and safeguard humanity's data. That's where we are now. This is most of the effort across the community is on this problem. We're already working on step 3, because that kind of work, the computation takes longer. But most of the attention is on step 2 right now. We're doing that through a combination of on-ramps and cryptoeconomic incentives, namely Falcon Plus. This is already yielding massive scale data onboarding. So we started putting significant effort into this at the sort of like turn of the year, and you can see the scale of throughput of the onboarding of the network. We're on the order of half a petabyte to a whole petabyte every day. So every day, half a petabyte to a petabyte of data, new data comes into Falcon. That is a huge amount of scale. I think that's like multiple times the size of many other decentralized storage networks every day. And so this is starting to become competitive with centralized cloud storage networks. Now, it'll take a while for us to refine all of the tooling and interfaces and so on to make it competitive for web applications, and so that's what's going to take a while. But in the meantime, what we want to do is bring together all of these valuable data sets to then, as we improve the software, make all of that data much more valuable. Think of this as data, in a sense, has gravity. It's very difficult and expensive to move around large amounts of data. So once you get data to a certain place and you replicate it in those environments, it's much cheaper and easier to move computation to that data. So what are people using it for? I like to divide it sort of in two categories. One is Web3 applications, and that's kind of small objects and so on. And two, large-scale data storage. So the Web3 style objects usually use these on-ramps like Web3.storage. There are tens of thousands of users for these. There's millions of objects being added and so on. But all of that amount of data is actually quite small. All of Web3.storage is around 200 terabytes, which is big when you compare it to kind of small, like traditional blockchains, but it is small compared to centralized cloud companies. Another on-ramp is NFT.storage. It's storing about 65 million NFTs, and these are things like images, 3D rooms, sculptures, games, items, and so on. There's also a whole bunch of applications being built. There are things like chain-safe files. I think the chain-safe team is around today and tomorrow, so you should go and check out. I don't know if there's going to be there might be a demo. I don't know. Definitely check out the application. Things like Slate, which enable media storage. So think of images and personal files and all that kind of stuff. Fleek storage, which is kind of like a Netlify style application that makes it easy to develop and deploy websites, and many more. Then there's things like video, music, and other kinds of media, so video conferencing platforms, music platforms, and many different kind of creator media type protocols. One of the things I'm really excited about is games and metaverses. So already there's many game developers starting to put all of their actual game assets on IPFS and Falcon. And one of the things that I think is like super cool is entire virtual worlds, like 3D rooms themselves, are being created as IPFS assets, backed up to Falcon, and then minted as NFTs. And so that creates a full economic loop to enable the creators of these rooms to build out all of this tech. When these start getting wired up and you add the ability to make them programmable, that's going to enable a whole other kind of layer to come online. Then there's hundreds of large-scale data sets, and these are really massive. In some cases, the sort of like the smallest size for these are like single terabytes. The largest scale is hundreds of petabytes. So some of these data sets are truly enormous, and they're well beyond what many other storage networks can handle. One of the things that's very near and dear to me is scientific data. So I started IPFS with the goal of enabling distribution of large-scale scientific data because there's this huge problem around just coordinating the collection and gathering of the data, the curation of that data, the governance of that data, and just dealing with the bandwidth costs of moving around this massive scale of information. So it's fantastic to see this kind of use case coming online. And so, there's one group at Berkeley dealing with outputs of neutrino experiments, which generate petabytes of data, and all of that is going to go into Falcon, which is super cool. There's also things like large civic data sets. So think of the data sets around, like for a city, things like mapping, things like infrastructure records, and so on. Those data sets can come online into Falcon. The reason Falcon is really good for these kinds of things is because it provides archival features like verifiability of the storage, and you get a cryptographic, an actual auditable cryptographic trace of all of those operations, and making sure that the data is being stored You know where it's stored, who's storing it, and so on. Plus, it creates this content ID based retrieval, which creates a data commons. So there's a very different approach to storing and enabling data storage on the web. If you do it in a centralized cloud platform, you still address everything based on that source cloud platform or some DNS name that you own or something like that, and you still are creating a choke point for all of that data and all the control of that data. If you instead store it with things like Falcon, then you get to address the data by content ID. And that means that you could actually have a proper data commons, and you can treat the data as public infrastructure. It's a fundamental shift in how to deal with data. All of this is enabled by the cryptoeconomic primitives of Falcon, things like Falcon Plus, which is a program that brings massive affordability to large-scale data storage. We're talking about many orders of magnitude cheaper than centralized cloud providers. And so enabling that kind of pricing is what is enabling this huge growth of data onboarding into Falcon. This is also enabling new economic structures. Right now, while the capacity of the network, which is 17 exabytes, is greater than the amount of data stored, which is about 100 petabytes and growing. It's growing. The data onboarding is growing faster than the capacity. So at some point, if the growth rates continue like this, they're going to cross at some point. But while there's less usage than capacity, and so there's kind of open space, so to speak, then you can enable negatively priced storage, which is a super valuable primitive. Think of it kind of like negatively priced oil. Have you heard of negatively priced oil before? Like when at some point you're like getting paid to receive oil, which is kind of like a crazy moment in like supply chain economics. This is a similar kind of structure you can enable with CryptoEcon. You can, by causing the capacity build out and then the data onboarding to follow, you can create negatively priced storage, which can then bring massive scale data sets into the network. Then from there, you can build data DAOs. So you can use all of the DAO tooling that people have been refining for other community organization. You can enable that to be applied to this problem around collecting, curating, transforming, and governing data sets. This is one of the things that I think is super exciting about Web3 tooling and Web3 tech, is to build these public data commons of digital infrastructure. So when we get to, once the FEM ships and you can start building these things directly on Falcon, we're going to be able to do these kind of groups of participants curating large-scale data sets, governing the use and the licensing of the information, and potentially monetizing the use of that data too. Like you can imagine a group gathering their data, and that group charging participants for using that data. So this is what it can enable all those visions around letting users and organizations monetize their data from large companies using it and so on. We're also building the CDN component of Falcon, the retrieval markets, and so this is there's a lot of groups developing this at the moment. There's already really cool experiments. I think these will come online sometime in Q3 and Q4, and so we should be able to get sub-second retrieval for all of the data on Falcon, which will be super awesome place to be, or at least for the hot content, like the content that the 99.99% of the content is retrieved. There's also a growing startup builder ecosystem, so there's a ton of projects that are turning into startups themselves, so things becoming either new crypto networks or companies or things like that, so there's a ton of opportunities. Very excited to see there's a hackathon here as part of this event. That can help generate a bunch of new ideas that can help teams build solid relationships. It can help teams experiment with things and eventually create a project that becomes bigger. And to support that, there's all kinds of grant structures to enable people to kind of take the next step and so on. So that's what the whole community is doing to onboard and safeguard humanity's data. Now let's talk about bringing computation to the data. You heard a lot about FVM today. So there's a pathway this year of bringing programmability and smart contracts to the Falcon network. Beyond that, so the first part is getting smart contracts and programmability layers in place. Beyond that, we can build computing networks on top of that. So Bacalao, which we heard about earlier today, is an example of these compute over data networks, and it's prototyping a ton of the tooling required to build this infrastructure. What you want to be able to do is to run computation on the data, move the functions to where the data is located, compute there, and generate derivative data sets and so on, and then return the results. And so this is like the traditional model of task scheduling. So think of it like EC2 or Lambda or Cloudflare Workers and so on. We're building that kind of computing platform around Falcon storage providers. So this is both an additional revenue source for Falcon storage providers, but it enables those participants that are bringing data to the network to enable computation around their data. So I have a claim that there will be many different computing networks because the cryptographic requirements for making different kind of models work are very different. And so you end up in a world where there's very likely to be many different computational networks. And so Falcon will be an excellent L1 home for a lot of those decentralized networks. So we're tuning a lot of the direction of Falcon to enable many of these computational networks to emerge on top. And again, I'll talk about this and kind of why I think there's not going to be just one computational network. There's going to be many. It has to do with the cryptoeconomic constructions that you need to use things like zero-knowledge proofs and fully homomorphic encryption and optimistic computation and so on. And beyond that, we're also working on scaling the consensus layer. So this is, it was referenced earlier, we want the actual transactional throughput of the chain itself to scale to billions and then trillions of transactions per second in aggregate in the world, and to get to very fast local finality. And so the example that I use that we want like the blockchain level security with the centralized cloud performance, and so the world needs to get there. And so there's many orders of magnitude of throughput to increase. There's really good ways to get there, and this is what this project is about. All of that together will then enable massive scale data science. So take your science data and then do data science on it. So this is what you can get once you put in place all of that data onboarding, and then you enable computational primitives on top. So this is going to be, I think, super, super exciting. And using that, we can then build web-scale Web3 applications. And so we can finally cross the chasm and build actually decentralized apps that can run our day-to-day operations, right? So today, all of us are still using centralized applications because no single decentralized network can handle the kind of transactional throughput that even something like Twitter needs. So let alone something like YouTube or other kinds of networks. So what can you do? So if you are excited about this, join the community. So great, like you took that step. You're now here. You're in FIL Toronto. There are other FIL meetups happening in the world this year, FIL Singapore and FIL Tokyo. And help onboard and safeguard humanity's data, and then bring compute to the data. Thank you very much.